right, I'm going to record it because Matt's in Florida. All right, so here we go. So it says a particle moves along the x-axis so that its velocity at time t is given by v of t equals negative parentheses t plus 1 times sine of t squared over 2. They always have these questions, and they always say the particle moves along the x-axis and so on. A lot of times when they say particle moves along the x-axis, they use x of t for position instead of s of t. So just kind of look for that. If it's x, it's just moving right and left. Okay, so it says at time 0, the particle is at position x equals 1. That is always very important. That is your initial condition. So that usually means there's going to be some kind of differential equation where you're going to have to find a c using that initial condition. Okay. So it says find the acceleration of the particle at time 2. Okay, we have the velocity. How do we find the acceleration? Yeah, we do the derivative of the velocity. So a lot of times if you just write v prime and you don't even get the derivative right, then you get a point just for writing v prime of t. So in this case, v prime is going to be, oh, I guess we just need, this is a calculator one, I think. So we are allowed to use our calculator. So we could actually plug in, we could do our n deriv. Do you remember the n deriv? So we're going to do math 8, which is n deriv. And mine is old and it looks like this. So it's going to say v of t, so I'm going to do negative t plus 1 times sine of, I guess I'd do x plus 1 actually. And you don't have to write your setup on the actual AP test. I'm just doing it for your notes right now. And then it'd be comma, x, comma, the x value is 2. Is that what it was? Time at 2. Yeah, so that's that. Make sure you're in the correct mode, which is radians. So I'm going to do math 8. And some of your setups, remember, will look like d dx. Well, I guess you put it in the x of something, which is that, and then evaluate it at, and you put an x equals 2, like that. So what did we get? Did anybody do it? You're making me do it?
I got negative 105. So 5, that's great.
Negative 105. Did you guys get that? Anybody second it? No one wants to second for you. Oh, I'm hearing that's not what I got. Uh-oh.
Peter got
it. Did he? All right, I got 1.588. Did you guys get that?
I was close.
All right. All right, so 1.588. Okay, and you always want to kind of look around for units. In this case, there aren't any units. It doesn't say anything about seconds. It doesn't say anything about like feet, miles, or anything. So we leave it like that. Now it says, is the speed of the particle increasing at t equals 2? This is a very difficult question. All right, a lot of people have a really hard time understanding this, even AP Calc teachers that I've met at conferences. So, I know, terrible. All right, so is the speed increasing? In order for the speed increase, does someone know this from physics? In order for speed to increase, let's say velocity is positive. If the velocity is positive, then the acceleration needs to be positive as well. But if your velocity is negative, your acceleration needs to be, does it need to be positive or negative? So let's think about it. So let's do a little rough sketch of the velocity. Okay, so let's say we're down, we have some kind of graph like this, something like this, and this is our velocity graph. This is not what this velocity graph is at all. I'm just kind of telling you this different situation. So let's say we have time, and then the velocity, you know, goes from 1, 2 to 3. We'll make it easy. Negative 1, negative 2, negative 3. Okay. Let's say I'm on this interval right here. Is my speed absolute value of velocity, right? Speed is the absolute value of velocity. Is it increasing or decreasing? My speed is increasing. I'm going from a speed of 1 to 2 to 3 and so on. Okay, it's getting bigger. Okay, in this instance, my velocity is greater than 0 and my acceleration is positive as well. The slope of the velocity is positive. Okay, but let's say I move locations. What if I'm down here? Is my speed increasing or decreasing? It's decreasing. Trick question, right? Because I'm going from the absolute value of velocity is 2, 1, 0, and so on. The speed, which is the absolute value of the velocity, is getting smaller. Right? It's going from 2 to 1 to 0. Do you guys understand? This is happening when my acceleration is positive and my velocity was negative. Okay, so what's the rule? If my speed is increasing, what do I need to happen? I need a positive acceleration and a positive velocity. Or, what about here? What if I have that? See how the speed is increasing? The speed is 1, the speed is 2, the speed is 3. Speed is the absolute value of velocity. It's getting bigger. Does that make sense? What's happening there? The velocity is negative and the acceleration is negative. So I need for both of them to have the same sign. So that's what this question is saying. It's saying, is the speed increasing at time 2? So we need to figure out what the acceleration and what the velocity are at time 2. So we just did the acceleration at time 2. It's positive. What is the velocity at time 2? Well, let's plug it in. I have negative 2 plus 1 times sine of 2 squared over 2. So I get negative 3 times sine of 2. And negative 3 sine, did I do that right? Sine of 2 is negative 2.729. It's negative. That's a 2. 728, sorry. Pretend your teacher knows how to round. It's like pre-algebra skills there. All right, so this one is greater than 0. The acceleration is greater than 0. And velocity is less than 0. So since they have different signs, the speed would be decreasing. So v of 2 and a of 2 are not the same sign. Therefore, the speed is decreasing. So it didn't say the velocity, it said the speed. You have to be very careful. Speed is the absolute value of velocity. All right, B. So it says find all times t in the open interval 0 to 3 when the particle changes direction. Justify your answer. Okay, this is totally a graphing question. Okay, so what we're going to do is we're going to go ahead and put in the velocity in for y1. So I'm going to do negative parentheses x plus 1 sine of x squared over 2. And I'm finding on the interval 0 to 3. So if you want to change your window, so that it goes from 0 to maybe like 3.5, just to be on the safe side, just in case it does right before 3. You can see it. All right, and I end up getting a little graph that looks like this. Do you guys get that? Okay, what I'm really interested in is if it crosses the axis there or not. So what I'm going to try to do is I'm going to see if there's a maximum there. I'm going to do left bound and right bound to see if it like went up above the axis, or you could do like a zoom box to see. Okay, and when I do that, I found the maximum there, and our max was at a height, so 0.111. It was negative 0.006. Okay, so what does that tell me? It's negative 0.006 for that maximum. Does it go above the axis? No. Do you guys understand what I'm saying? Okay, so what are we trying to find here? So find all times t in the open interval at which the particle changes direction. What needs to happen in order for it to change direction? Your velocity needs to go from positive to negative or negative to positive. So when does it happen? Just right here. That's the only place where it happened. So it happens one time. So B, our answer is, we need to find it, so we're going to do second trace 0. And I'm going to get really, really close. So left bound, enter, right bound, enter, guess, get right where I think it is. And it's at t equals 2.507. And then it says justify your answer. The AP Calc test always says that. Usually when it says that, it gives you a point for justifying. So say it happens at t equals 2.507 whatever seconds, minutes, whatever it is, 2.507, because velocity changes sign. That's all you need to say. You don't need to say positive to negative, negative to positive, or anything like that. You can just simply say the velocity changes sign. Okay, C. This is what we were kind of doing last time. So find the total distance traveled by the particle from time t equals 0 until time t equals 3. Okay, total distance. Do you guys remember how we did it? So distance is going to be, yeah, you're going to integrate v of t dt, but what do you need?
Absolute value.
Absolute value. So as long as you write that, you'll get a point. Now it's saying from time 0 to 3, so you would definitely need your limits of integration too, your 0 to 3. You would probably get a point just for writing that. Now you can always save yourself some time. We've already put that velocity function in for y1 at this point, right? And if I would have been smart, I would have done this before I even did part A, because I would have noticed, oh, I'm going to have to graph velocity eventually. So anyway, so I have velocity in for y1. You don't have to keep typing that in every single time. So now that I'm getting ready to do math 9. Do you guys see that? Like I need to do math 9. So I'm gonna hit math 9, and I want to put in the 0 to 3. Or if you have the old setup like I do, like at the very end, you're gonna have x comma 0 to 3. And I want the absolute value, so I'm going to do math, number, absolute value is choice 1. So it might look like, do you guys have it like n deriv? How many of you guys have n deriv? Or not n deriv, sorry, f and ent. How many of you guys have, like, it looks like this on your screen, f and ent? Raise your hand. Okay, how many of you guys have this? Okay, most of you guys have this. So if you have f and ent, you're going to do absolute value, and then we want to get y1 in there. Okay, and you guys are to the point, if you had this on your screen, you have the 0 to 3, and you want to get the absolute value part, or you did the absolute value. Now you want to put y1 in. Okay, here's how we do it. So on your calculator, do you guys see vars? It's underneath your cursor. Vars. So hit vars, arrow over to y vars, stands for variables. Function, y1. It takes whatever you have in for y1 and it puts it there. So you don't have to continue to like type in the entire function every single time. So this is great when you have really complicated functions. Do you guys see it? So you do vars, arrow over to y vars, function y1. And then you would do x 0 to 3 in this one, or in this case, you just do dx. Okay, and hit enter. When you do that, and you don't have to show this setup or anything on your AP Calc test, but when you do that, you get 4.334. That's 4. Okay. What if I had said displacement? What would be the difference? No absolute value, right? All right, D. During the time interval 0 to 3, what is the greatest distance between the particle and the origin? Show the work that leads to your answer. It is displacement. You want to talk about the displacement. Looking at your function, think about when you look at your graph. So going back and looking at this graph that I have right here, what would that mean? How would I find the greatest displacement? Kind of, but this is the velocity function. This isn't the displacement. Yeah, so we need to kind of do something with integrals. Okay, here's what we're going to do. I want you to think about different times when something important is happening. Okay, when you have this graph that's going down and then back up, what does this mean? Like when I have the velocity function down here, what does that represent? That area represent? How much it's changed, right? From where you started. Where did we start at time 0? Where were we located? At 1. You guys see what I'm saying? So at 1. So I want you to do like a little chart, and I want you to say at time 0, we're at location. So maybe I'll write location or distance or something. I'm at location 1. Okay, and the point that mattered was this point right here that we found in B, 2.507. Okay, if I integrate, so if I do math 9 and I integrate from 0 to 2.507, it tells how much I've moved during that entire time period. So I'd put in y1, and then I would integrate dx. Notice I'm not putting absolute values in it. So I'm going to do math 9. If you want this number, 2.507, that is the last x value that you just found, right? If you just put in x, like it's stored, you'll be fine. If you need to check that that was the value, you can hit X on your main screen and hit enter. Remember we talked about storing values a long time ago. And make sure it's that 2.507 thing. And then maybe store it as A, just to be on the safe side, in case you find another value on your graph. Do you guys remember doing this a long time ago? Okay, so I'm going to do math 9, and I'm going to go from 0 to X, or in this case, I just stored it as A. And I'm going to do vars, y vars, function y1, and dx. Okay, and when I do this, I get negative 3.265. So that means during that time interval, I've now moved backwards. So it's like I started at position 1, so imagine this is like my x-axis. I started at position 1, and now I moved backwards, 3.265. Where am I now? I'm at negative 2.625. Right, so 1 plus that. And then I want to add on this little bit right here that's now above the axis. Okay, so I want to figure out what happened there. So I'm going to do second enter. That's going to save me a little bit of time. If you do second enter, it pulls up your last equation. And I want to find what happens from A to 3.
It was the A value then?
The A was the 2.507. I stored it. But you can still do X if you have X. So I'm now doing from 2.507, whatever it was, to 3. And I want to find how much I've moved now. And that says during that time interval, I moved forward 1.068. So what did I have here? 2. Oh, I just lost I got rid of it, negative 2.266. All right, and then this was at time 3. I've now moved forward again. So if I have negative 2.266 plus this, I have negative 1.198. Did you guys get that? Okay, where's the biggest difference? Oh, so it says, what is the greatest distance between the particle and the origin? Show the work that leads to your answer. What's the biggest distance? Which one? I heard a mumble. Distance is positive, or distance, you're going to take the absolute value. It's the 2.266. So your greatest distance equals 2.266 units away. Does that kind of make sense? You want to look at those various important values and decide. Now, personally, I think you get to kind of to the point where you can see it, you can think of it as an area, but you do have to kind of consider that initial position that you started at 1. So it's nice to show all of these different steps. All right, so the scoring. So let's look at the different scoring. So on the first one, we got a point for our A of 2. We got a point for knowing the speed was decreasing, but we had to have a reason there. You couldn't just say the speed is decreasing. Okay, so you had to say they were opposite signs. So velocity and acceleration at time 2 were different signs. Number 1, you got a point for having the square root of 2 pi. So maybe this wasn't a calculator one. Surely it was, right? For having that, and 1 point for the justification. When it says limits, what it's talking about is the limits of integration. So for part C, they gave you a point for having the 0 to 3, limits of integration. They gave you a point for having the integrand. Integrand is the part right here, which was our y1. So you got that point for just writing y1. I guess maybe I should say we should define y1 somewhere. I should have written at some point, I should have said y1 is equal to the v of t if I start referring to y1, right? And then you get 1 point for your answer. You get 1 point for knowing that the distance, it's traveling a certain distance while the velocity is negative. So knowing that distance is positive, right? So you need to find all those different things and 1 point for your answer. So 9 points total. Does this kind of make sense? This one's a little bit easier. All right, so this is a very famous AP question. It was only a few years ago, 4 years ago, 5 years ago, I guess. So a squirrel starts at building A at time t equals 0 and travels along a straight wire connecting to building B. I don't know how these people come up with these questions. They're just random. So between 0 and 18, the squirrel's velocity is modeled by the piecewise linear function defined by the graph above. At what times in the interval 0 to 18, if any, does the squirrel change direction? Give a reason for your answer. So for part A, this is the velocity function. It says graph of the velocity, graph of V. So where is the squirrel changing directions? Yes, so the squirrel changes directions at t equals 9. And do I have seconds or anything? Did it say anything? No. Okay, t equals 9 and t equals 15. And then we need justify your answer, give a reason for your answer. So we're going to say because v of t changes sign. B. At what time in the interval 0 to 18 is the squirrel the furthest from building A? How far from building A is the squirrel at this time? So what do you guys think? When would it be the furthest from its starting position? No. No. Yeah, it's hard. You guys are thinking, I think you're thinking this is, so Lydia just said from time 2 to 8. That would be if this was the position graph. It's at 9. Good job, Bob. What does it mean? How do you know it's 9? It's the largest area, right? So what we're doing is we're finding, right, our distance is going to be from 0 to 9, and we're integrating that velocity function. You don't actually need a velocity function in order to integrate, so I wrote it with that setup, but what am I actually doing? I'm finding the area of this trapezoid. Okay, so it's going to end up being 1/2, base is 9, or what am I doing? 1/2 b1 plus b2. So what's this distance up here? So this was 9. What's that one? I can't read it. 20 to 20 what? 2 to what? 7? Okay, so it's 5. Okay, thank you. All right, and then the height is 20. Does it say 20? Okay. So 1/2 h times b1 plus b2. So we have 10 times 14, so 140. Okay, what happens after that? So what's happening during this piece right here? It's going back towards the building A. Does that make sense? So we're talking about really displacement. I use distance and it's positive in that part. Okay, so C. So maybe I should say at 9 seconds, or 9, maybe I'll write t equals 9. So at t equals 9, the squirrel is 140 units away. Really be helpful if they gave us some units, but whatever. All right, C. Find the total distance the squirrel travels during the time interval. So it's constantly moving. You've seen squirrels. They go crazy. They go forwards, they go backwards. They're doing a whole bunch of stuff. So if we're recording the total amount of distance that they travel, just like my cross-country runners, they would be very sad if I told them to run out 3.5 miles and come back 3.5 miles, and I said, okay, you went a distance of 0. That's not what they actually do, right? They go a total distance of 7 miles. Their displacement is 0. Okay, so what we need to do is we need to find all of these areas, which this one was 140. We need to find this area, and we need to find this area. So we're going to do 140 plus 1/2 base. What's this distance? Base 1 plus base 2. I can't see my numbers on mine. So it goes from 9 to what? 9 to 15, so 6 plus 4. And then the height, this total distance, I think it's -10, is that right? So 10. So we're using positive 10. We're using it all as positive because we're adding up all the positive measurements. So 140 plus 10 times 10, so 50. Okay, and the last one is 1/2 base. So it's like this, base 1 plus base 2. Can you guys see them? So 15 to 18, so 3 plus, what's this one, 2? Is it 2? And then the height, 10. So it's going to be 5 times 5, so 25. Okay, so we get a total of 165 plus 50, 215. Is that right? Okay, and then the last part says write expressions for the squirrel's acceleration, velocity, and distance from building A that are valid for the time interval 7 to 10. Okay, so if I was doing the acceleration from 7 to 10, so I'll do it real quickly. That's going to be the slope of the velocity function. So could you find the slope from 7 to 10? All right, and then what about velocity from 7 to 10? The velocity goes from, I guess I would need the equation of a line actually, because it would need to, you would have the equation of a line using that slope from 7 to 10. All right, and then the distance from 7 to 10, that would just be the area of that little triangle. Okay, does that make sense? Okay, so hopefully that's going to help you guys on your homework. So we're not going to finish that section like in the notes, because I feel like it's better to do the actual AP questions for this, but your homework is still due Monday.